So as I mentioned before, that probability of an event can be written as a fraction, as a decimal, or as a percentage. Okay? Now we want to focus on theoretical probability, and we can do theoretical probability best by showing sample space. So an example of the way we can show sample space is showing a tree diagram. So the event here is we're going to take this spinner here. So imagine there's like a little spinner arrow. Okay? There's some spinner arrow that we can spin around the axis here. Okay? And we're going to spin that arrow around, and as we spin it, it falls in one of these three categories, A, B, or C. So we're going to do this twice, so there's two events. So it's important to understand the number of events occurring, and we want to know the probability of spinning A, B, B, or C. Okay? So we want to look at the sample space here. Okay? Draw a little bit nicer arrow. Okay. So that's a really short arrow. And I'm going to point it right in the middle here. Okay, so we're going to spin the spinner around, and each outcome is equally likely. So that's kind of nice. Sometimes this is not the case. So we're going to spin this twice. Okay, and each spin is actually what we call independent. Okay, because the second spin doesn't depend on whether we got the first. If I got A the first time, it doesn't make it any more or less likely to get an A the second time. Okay, so we're going to draw this sample space out. So this is spin 1. Okay, and I'm going to draw it as a tree. Okay, so spin 1 has three possibilities. We can get A, B, or C. Okay, now we need to do two events to get A, B, B, or C. So if we got A, we're going to spin it again. We're going to have three more events. Okay, so it could be A again. Okay, this is definitely one that we want. We want A and A. Okay, so there's one possibility that we're looking for. Okay, then there's B and C. Okay, then if we got B, there are three new possibilities for B. A, B, and C. Well, this BB is one that we actually were looking for, so we're just going to highlight that one. Okay, we got B, and then we got B again. And if I got C the first time, I'm going to get three new possibilities, A, B, and C. Okay, and there's that other one that we're looking for. So we have three events that we're looking for. So to do this is what we call our sample space. This actually draws out all the possibilities. So with our sample space, we can then establish our probability. So probability of AA, BB, or CC. Okay, well, how many of the events are we looking for? There's three events here that we wanted. Okay, the AA, BB, CC. How many events are there in total? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 possible outcomes here. Okay, one of them was AA, the other one was AB, AC, BA, etc. Okay, so the probability works out to be 9 out of 3, and we can just leave it like that, or we can simplify it to 1/3 or write it as a percentage. Okay, but essentially the probability is 33.3%. Just going to clean that up a little bit. It's going to be B, B. So that's one type of sample space. Okay, we can do this one too. Okay, so you can pause the video and try this one on your own. So you should be able to do the same thing. So this one is a probability of a coin being tossed now 3 times. Okay, so here we had 2 spins. So this is 2 events. This is a 3-event probability. Okay, so we did 3 times. Here we needed 2 rows on our tree because it's 2 events. How many rows do you think we should have on a 3-event probability? Okay, so think about that. pause the video and see if you can draw this in.